Hi friends, this is Anusha back to you with a new video. Please subscribe our channel. If you like this video, share to your friends and let us go into our today's topic. So, reaction of acids and bases with metals. Reaction of acids and bases with metals. Here we will consider metal as zinc, isn't it? So add zinc crystals in this, and add HCl to it. What you will add? Add HCl to this. So after the reaction, the gas which comes out from it, you send it through the soap water. And so in that, the hydrogen, the gas which is releasing out will raise up, and here put some candle which is lit candle, and it will put off with a pop sound. By that you can say that hydrogen gas is H2 is liberated out. H2 is liberated out. So what happens when the metal is reacting with acid? When metal is reacting with acid, what will be forming? ZnCl2, salt, plus hydrogen gas, H2, salt. Metal, when it is reacted with acid, it gives out what? It gives out what? Salt plus hydrogen gas. Salt plus hydrogen gas will be coming out. And next, when it is reacting with base, when acids are reacting with base, for example, metal the same, NaOH will take. Then what happens? When metals are reacting with the base, so what happens now? Salt is formed the same, and H2 gas will come out. H2 gas will come out. What will be coming out? H2 gas will coming out. To balance this, I am doing it. Yeah. H2 gas. This is a salt, isn't it? Salt plus H2 gas. Salt plus hydrogen gas. But it is not possible with all the metals in the case of base. Okay, so when metal is added with the base, acid, metal plus acid will give you salt plus hydrogen. Metal plus base will also give you salt plus hydrogen. Metal plus acid will give you salt plus hydrogen, and the metal plus base will also give you the salt plus hydrogen. So when the reaction of acids and bases with metals will give you what? Metals plus acid. It will be any metal here, like copper, CuCl2 will come, magnesium MgCl2, H2 gas will be going out. Whatever the metal it will be, metal plus acid will give you what? Salt plus hydrogen. Metal plus base also will give you the salt and hydrogen. And see, reaction of acids with carbonates and metal hydrogen carbonates. Let us see. Carbonates. Na2CO3 is a carbonate. See, Na2CO3 added, and to that to this with a Testel funnel, the retort stand, test tubes 2 A and B, 2 test tubes, and from this test tube to the another test tube, test tube 1, test tube 2, you can say. Test tube 1 to 2, here CaOH2, calcium hydroxide is there. So what happens? So whatever the gas it is released, it is passed to this. Okay, this Testel funnel, why it is used to add, actually to add, in the laboratories they use to add liquid into it. So what, first you have taken Na2CO3 plus HCl. HCl you have added to it. Acid you have added. Carbonates plus acid. What it will give? It will, when some gas is liberated out, and that gas is passed through CaOH2, then it turns into what? Milky white. then which indicating that it is a carbon. So when a carbon is added to the lime water, it turns into milky white. And when a hydrogen gas is liberated out, when you test with a mastic or a candle, it will put off with a pop sound. When oxygen is there, it will burn more. So different gases, you can't smell it and say it is that gas, no. So like that, calcium hydroxide added. So what, this CO2 gas is passed through this. So what happens when carbonates react with what? Acid. Will give you what? Salt plus water plus CO2 gas. And metal hydrogen carbonate, when sodium hydrogen carbonate, when it is reacted, sodium hydrogen carbonate, when it is reacted with metal hydrogen carbonate, reacted with HCl, what it will give? It will give salt plus H2O plus CO2 out. When you pass that CO2 to the water, this reaction, they have taken, asked you to take in test tube A, this solution will take place. In test tube B, this solution will take place. Both the solutions, when you pass through CaOH2, in the both the solutions, the gas, if you pass through CaOH2, that will be taking place. So calcium carbonate plus H2O will be forming. And more if you add it, more and more carbon dioxide if you add it, CO3, then again, what happens in that CaCO3 will be forming as what? Precipitate. In that CaCO3 forms as a precipitate. If you add more, then it forms CaHCO3, which is, this is soluble in water. This is soluble in water, but CaCO3 will be forming as a precipitate. So what? Blindly, metal plus metal carbonates plus acid. With the acid it gives. Then what happens? Salt plus, what will be giving out? Salt plus water plus carbon dioxide will be giving out. The same metal hydrogen oxide. Metal hydrogen carbonate reacted with acid. What will be giving out? The same will be giving out what? Salt, water plus carbon dioxide. So till now you saw acids with different things. These are acids with metals, metal oxides, carbonates and all we saw. We will see one of the important topic in this, that is neutralization. So when you feel upset with your stomach or when you feel acidity in your stomach, then you will put some antacid into it, isn't it? What? Or Eno or soda into it, which makes your stomach out of upset. But what is the reaction taking place in it? What is the reaction taking place? That is nothing but your neutralization reaction. What reaction? Neutralization reaction. Neutralization reaction. Neutralization reaction. You saw with acids where it turns red to blue, blue to red, okay, everything is fine. Then what happens if an acid is added to base? If an acid is added to base, what happens? If an acid is added to base, what happens? So take one test tube. Add NaOH to this. NaOH. Add NaOH and add phenolphthalein solution to this. Phenolphthalein solution. Then it becomes what in color? It becomes what? Pink in color, you know. Pink in color. And now add some HCl to this. Add some HCl to this. Then you added phenolphthalein solution base to the base you have added phenolphthalein solution, it turns to pink. If you add HCl solution to it, again it becomes colorless. Colorless. By adding this HCl acid, it nullifies the base. It nullifies the base in NaOH. It becomes colorless. Again, if you add NaOH, in that, what happens again? It gains pink. Again, NaOH. It's NaOH and HCl. If you add this in this solution, after some time there will be no reaction in the solution, which means that it does not go to pink or it does not go to colorless. Means what? It is no more an acid or a base. No more an acid or a base. Then what it is? No more an acid or a base. Then what it is? Then when acid plus base is added, what will be coming out? What will be coming out when acid and base is added? Salt plus water. What will be coming out? Salt plus water will be coming out. When acid is reacted, acid plus base, acid with metal, acid with base with metal, acid with metal carbonates, acid with all use. But acid plus base, if you add, what happens? Salt plus water will come out, which becomes neutralization. This reaction is called as neutralize. No more the solution is an acid or a base. It is the acids and bases and neutral solution will be equal. You can say they are in equal amounts. So what happens when acid is reacted with base? Salt plus water. So metal oxide is a base. Why? See, the same reaction. Acid plus base will give rise to salt plus water. The same thing. Acid plus metal oxide is also gives rise to salt plus water, which is same as neutralization reaction. So metal oxide, you can decide it as an what? Base. Then take what you will take? CaOH2, which is base, isn't it? Plus CO2, carbon dioxide you take. Then what will be coming out? CaCO3, water plus H2O will be coming out. Means what? Here also see. Base plus carbon dioxide. Salt plus water is coming out here. Salt plus water. Means what? The same. This is base. So what should it be to become salt plus water? What CO2 should be? CO2 should be what? Acid. Isn't it? That's why now base plus acid will give rise to salt plus water. C is a carbon, is a non-metal oxide. Non-metal oxide. C is a carbon, isn't it? So it is what? Non-metal oxide. Non-metal oxide. Non-metal oxide. Means what? Non-metal oxides are acids. Metal oxides are base. Because when you add, see, acid plus base will give you to salt plus water. The same reaction takes place in your stomach also. Your stomach is full of acids. If you eat more acidic, HCl will be there. And if you eat more acidic if you put more acidic into it, it becomes more acidic, isn't it? To avoid that acidic, what you need to do? You need to put antacid or eno into it, so that it becomes what? Neutralizes. The reaction which takes place is neutralizes. Even what? Metal in this reaction, what happened? Acid plus ZNO, metal oxide, will give rise to salt plus water, which is nothing but salt is nothing but water. Metal oxide. Same. Metal oxide is now what? Base. Acid plus base will give rise to salt plus water. Here base plus CO2. Acid will give rise to salt plus water. So non-metal oxides are acids and metal oxides are base. Metal oxides are base. Now, see. Now experiment I'll show you. Take one beaker, and this is switch, key, switch. This is what? This is what? This is bulb. Bulb, switch, key. Now here in this, you add what? H plus ion will come out, from the acid. First in this, if H plus ion is split out, then if this key switch is on, first in this you add some HCl in this and check whether the bulb glows or not. Yes, bulb glows. Next, any acid, H2SO4, any acid you take. Next, glucose you take. What you will take? Glucose. Bulb does not glow. Next, you take alcohol. Bulb does not glow. What does it mean? Why the bulb is not glowing? In this acids, ions are splitting out. What are those ions? We saw H plus ions. What are those ions? Those ions are H plus ions. What are those ions? Those ions are H plus ions are splitting out. When see, in the electrolysis process, when this is added in the aqueous solution, when an acid is added to the water, so what happens? It will split into, H plus ions will come out. We saw, isn't it? HCl plus H2O. We saw H3O plus. H ions will come out. H plus ions are going to, positive ions are going to come out. Hydrogen ions are going to come out. That's why the bulb will glow. In the case if you add glucose, C6H12O6. If I add C6H12O6, they are going to glow. C6H12O6, they are going to glow. No, they are not going to glow because there are no positive hydrogen ions in that. There is no positive hydrogen ions in that, so that they are not going to glow. In the case of alcohol, C2H5OH. In the case of alcohol also, there are no positive H plus ions, so they are not going to glow. So from this, what you can conclude, there are splitting of H plus ions takes place in the case of hydrogen, which makes the bulb to glow. And next experiment comes to you. See, next experiment is weak and strong acids. We have discussed already, but still in a part of a lesson I'm telling you. Strong acids. The same bulb experiment, take one beaker, same bulb experiment you take, see, add HCl solution. The bulb will glow very, very brightly, the bulb glows. CH3COH, take CH3COH. CH3COH is also a acid, it's an acetic acid, we call it as, isn't it? CH3COH is also a acid. Take CH3COH in this, take CH3COH, acetic acid. It glows very lightly, dimly, very light it glows. Why? In the strong acids, completely the hydrogen will dissociate. In the strong acids, complete hydrogen atom will get dissociates. Where in the case of acids like CH3COH, we saw only one hydrogen atom will come out of 4 hydrogen atoms. So they are called as weak acids. So the bulb will glow dim in weak acids when compared to the very strong acid. So the hydrogen concentration of acid depends upon only the concentration of acid only depends upon hydrogen gas dissociation. Hydrogen gas dissociation.